I've been thinking about building a Fender Deluxe, the 5E3, like Neil's. And I thought, well, I wonder if I have enough parts just laying around that I could actually throw this together. And what I don't have, maybe I could manufacture. I was doing a little search here. I come up with a number of parts. Got my parts list made out here. Look in the stash box here. Yeah, there's a switch. Need 3 octal sockets and 2 miniatures. So let's see if I can find a couple of matching ones. Oh, okay, here we go. Get it out of there. Yeah. Well, there's a couple of nice octals. Let's see, is there another one hanging in here somewhere? Oh yeah, here we go. Alright, so far so good. Now here's the cab I'm going to use. I built this back in '97, and it was built on the dimensions of a Fender Deluxe, a Tweed Deluxe, but I never put one in it. I've had various experiments in it over the years, but I think it'll work out pretty good. Yeah, it's made out of, I think it's probably pine or poplar, and it's a little dirty in there. I even finger jointed all the corners. See, I gotta re-glue some of the Tolex just in a couple places, like here, right there, because they're coming out. But other than that, it's pretty good. Yeah. And I also have this speaker. I've had this for a number of years, and I've been waiting that I knew someday I would build a Deluxe, and that's the speaker I wanted to put in it. So now we've got to find some transformers. Alright, transformer stash box. Let's see what we got. Yeah, let's see here. Jeez. That is a Deluxe output transformer. Yeah. I don't think I'm going to have a power transformer, but I was pretty sure I did have an output. Alright, what's this guy? That is also a Deluxe, but it's a hot rod Deluxe, and it's not going to have the 5-volt winding needed for the 5Y3. I think that's what I'm going to run into here. Here's an interesting fellow, military. It's got a schematic on it here somewhere. Oh yeah, right on top there. Yeah, that baby puts out some voltage. I won't be putting that in it, but I may be using that in a power supply at some point. We know we've got an output. That's one step closer. Well, I was looking through my stash and I found another transformer that I'd forgotten about. It's really nice. It has, here's the primary, 5-volt winding. We've got a high voltage winding here with the center tap, and we've got our filament voltage, 12 volt, with the center tap. Now this is a little bit smaller outside dimensions than the Tweed Deluxe transformer. It's 2.5 by 3. Okay, here's the Champ transformer, and its outside dimensions are 2 13/16 by 3 3/8. So it's larger in that sense, but the stack of laminations, and that's this part here, the stack of the laminations is 1.4, whether on this one it's 1 3/4 inch. Okay, So if we look in the Temple catalog, we can see how to size the steel. Now here's the Temple steel site. Let me go to Products, Transformer. Okay, here it is. Standard Offerings Catalog. These are the standard laminations. Okay, here we are on the 1-inch page. And if you see the outside dimensions, they are 2.5 by 3. Okay, so that matches the outside dimensions of the transformer we have. And the lamination is named with this, the center leg. It's 1 inch. So you call this a 1-inch EI. Okay, so that's how that works. Now let's go up to the 1 1/8 inch. Okay, and it also matches the outside dimensions. Okay, we can see again, so the center leg is 1 1/8 inches wide. So that lamination is EI 1 1/8. Okay, now that we've looked in the Temple catalog and we see how the width of the center leg of the steel, if we take the width of the center leg and multiply that by the stack, that gives us the cross-sectional area of where the flux flows through. The larger that area, the more flux it can take. So if we look at the cross-sectional area of this transformer, which we can, and compare it with this one, we'll know if this guy can handle, approximately, if we know this guy can handle the power required. So the Tweed transformer here, if we multiply the center leg, which is 1 1/8, by the stack 1 3/8, we get this square inch amount right here. But this guy, 1 times 1 3/4, we get 1.75. So we are, this guy can definitely do it. Now there's a difference here where it's kind of nice on this that the leads come out of one side. That way the transformer can lay down and be mounted on the chassis like that. This isn't like that, so we'll just have to drill holes and have two holes here and 4 holes for the mounting. But it should still work. This came out of an old reel-to-reel in the 1960s, and if this date code is correct, or if I'm reading it correctly, it would be the 44th week of 1961, which seems about right. This transformer is pretty cool too because it has what's called a shorting band. This band goes under these covers and on the outside of the coil, and you can see it completely encompasses the coil, which helps keep out radio noise and just other noise from getting in. And you can see that it's soldered to itself. You might think that, well, that's like a shorted turn, but it's out on the edge of the laminations. Most of the flux is centered in, inside. So yes, it will bring the exciting current of the coil up a little bit, but not that much. There's also something else. Let's see if I can, okay, right here. You see that? It's a little braid wire that comes out and it's stuck between these laminations. What that is there's a shield in there, just like on the schematic of this guy. You can see this orange and this dotted line. That's a copper shield that's in there, and it's in between the primary and the secondaries. And what happens is, say there's a bunch of noise in the primary, the line coming into your house or wherever, it's going to get in there. And a transformer is kind of like a capacitor. You could consider this a plate and these plates. So AC noise is going to get through there. But if you have a shield connected to ground, the noise comes in and hits the shield and it gets shunted to ground. So that's how that works. And the other important thing about a shield, it can't be soldered to itself like this one on the outside. It has to be insulated from itself. Otherwise, it's like a giant shorted turn, and the transformer will burn up. It'll draw tons of current and burn up the primary winding. Well, the core is big enough. let's see what the open circuit voltages are. Turn on variac. We got, let's see what we got coming in. 116. Okay, let's check the 5-volt winding. 5.61, that's cool. Now the filament winding. Yeah, 7.11. Got a center tap. Check the other side of the center tap. Yeah, looking good. Now the high volt winding. I have the schematic that I took offline for the Tweed Deluxe transformer, and they have, although they have, well, they have 355 volts under load. That's to the center tap, and down here in the open circuit to center tap they have 380 volts. So let's see what I get. Look at that, 383 volts. Okay, it'll be a little bit higher than that because we only have 116 coming in, but that's, I'd say it's close enough. So yeah, we can move on. Well, here's my chassis. These used to be signs at work when we had lead solder pots, but now that we're lead free, they didn't need these anymore, and they're pretty sturdy, steel. So there's the other side. I must have painted a pick guard on there. So I may just make this the inside. You know, of course it won't be this big. 14.5 inches as long is what the chassis is, and that's about from here to here. So I'm thinking maybe just leave this in here. After I cut out the chassis and bend it, you know, and everything, I can make the decision of painting it, or, you know, just going over it and painting it. I think what I might do on the control panel, since the original ones are chrome plated, I'm not going to get this chrome plated, but what I could do is take off all the paint down to the metal and make it really shiny, and, you know, the steel, and then clear coat it after I put the decals for the volume and tone and so forth on there. We'll see how that goes, but that ought to work. Lead work area. Yeah, I just had a thought. What if this really does say lead work area? Poison, the band Poison. This might be a sign for his, like, side of the stage, because it was so loud and intense. You know, it was a warning to people. Well, could be. All right, there we go. Now we just got to bend it. Gonna have a lip here and a lip here. There's the side, and there's the side, and there's the back. Right on. Here's the other side. Lead work, Poison. Here's my homemade metal brake. The same guy that taught me transformers gave this to me. Let's see, which one should we bend first? I guess we bend the inside one first. So we are going This isn't the most precision. This isn't the most precision metal brake in the world. That'll work. Yeah, now I'm going to make a little part for the end. I won't show that because it's basically the same thing as this. But yeah, you can see it's a little off there. But I think it'll draw in when I put the other part on. Warning. Let's see. Poison. Lead work. That's kind of cool. Yeah. Probably, maybe I'll just leave this on here and leave this on here, and then on this side I will just take it down to the bare metal, and then that's where the control panel will be. So then I'll mark the various controls and then clear coat it. There, I re-squared that up so she looks a little better now. This is probably the easiest way to make sure that the old holes are going to be aligned right. So I'm just going to do it the old-fashioned way. Just kind of eyeing this up. This is a mock-up, of course, just to see if everything looks good. So yeah, I'll probably do it largely by eye, mark it out, and then drill it out. Almost forgot the power switch. You like slug busting? I know I do. I bust all my slugs with Greenlee slug busters. Yeah. Look at that. Look at that cool box. Yeah, metal metal reinforced corners. Greenlee. You want to bust slugs? Bust with Greenlee. And who doesn't want to go out and bust some slugs? Busting makes me feel good. We had a breakthrough. A breakthrough. Yeah. Greenlee slug busters. That's how I bust slugs. Yes, sir, folks. Greenlee slug busters can fulfill all your slug busting needs. Got a heavy day of slug busting ahead of you? You want to go with Greenlee. The same guy that gave me the metal break gave me these slug busters. And thank goodness he did, because I wouldn't be busting slugs without him. Another slug busted by Greenlee, the king of slug busters. Here's what I'm going to use for a circuit board. It's a piece of phenolic electrical board. They use this where I work, and I got a big piece of it a few years ago, and I've been cutting off ever since. So it's a scrap piece. It's a little ragged along here, so I'm going to recut this. And it's going to be the same width as the original fender, but it's going to be a little longer to allow me to be able to drill holes for standoffs on either end. So let's get cut. I found a layout of the circuit board online, and you can print it out, full size. His circuit board was a little wider than mine. I think he made it wider for bigger capacitors, but I wanted to make mine the original width. So what I'll do, I'll cut this out and just cut it down the middle and then squeeze it in and use some two-sided tape to put it on here, and then I can drill it out. Patterns on the circuit board. We're ready to do some drilling. These are the rivets that you use to solder the components in. Go in here. So everywhere the hole is, there's going to be a rivet through there. Let our factory trained technicians paint your amplifier chassis in our specially designed, hermetically sealed environment. Call now. The chassis now has all the holes punched in it, and it has a coat of clear coat on it. This came out pretty good. I had to redo it. I had taken a Sharpie and written, the controls, but then when I put the clear coat on, it just faded it away. You can see here a little bit left. So I had to sand it again, and actually I think it looks a little better. But look, this hole, maybe these holes are down this way a little bit compared to these. Just a tiny bit. And this hole, here's the center line, this hole's right in the middle, but this hole, a little high, that's a little high too. Well, if the whole alignment inspectors come along, I'm going to be written up. They might even make me get recertified. Better get this thing together. Well, two of the capacitors I found in my stash had the right value, but the leads were too short, so I had to add on. I know that's frowned upon in some circles, but the whole thing here was to use up parts that I had and see if I could, scrounge up enough stuff to get this thing going. So we'll be all right. I did use the double hook method, so she'll hold up okay. And March 12th, 2022. What a fine day for building an amplifier. Yeah. And I think I've got all the parts together now. I've got some, these are old wires from old computer power supply that burned out. I thought I could recycle them. Good wire. I got something to follow. And a cup of tea. Ready to rock. We're ready to put the chassis together. All right. I had to re-drill. There we go. All right. Had to re-drill these holes. Control panels there. Tube sockets. I'm using a cliff jack on this because I don't want the secondary of the output transformer to be grounded. I just want it to go directly to the speaker. I think when I use attenuators, that may cause less of a grounding, grounding issue or ground loop issue. Oh, would you look at that? Transformers are in place. Now all we have to do is wire it up. Everything's wired up except for the preamp tubes. Got these guys. You can see right here all these wires. They're the preamp tube wires that have not been wired in, but everybody else is there. All the wiring is complete, I hope and I think. So we will get ready for, I guess we'll put the rectifier tube in and see how the voltages are. Alright, she's back in the cabinet. I didn't try anything yet, but I'm going to stick the rectifier tube in and check some voltages. See if we get lucky and we don't have any mistakes the first time. Wouldn't that be neat? Alright, gonna bring it up from 0 slowly. We got a rectifier tube in it, 5Y3. So I'm gonna bring this up a little at a time. This is the input voltage, and this is the voltage. This will be the DC voltage on the plate, though I don't have a tube in there yet. The tube isn't conducting yet. It looks like she's starting to warm up though. No smoke yet, that's always a good sign. Almost up to 500 volts. And that's 116 volts is the most I'm going to get. Okay. Well, here's a major screw up. Here's where my 6V6 is supposed to go. Oops, can't go in. This one goes. The speaker's too high. That's what you get. I'm either going to have to use a different cabinet or get a different speaker. That's too high. Oh, the tragedy of it all. Yeah, I guess I should have checked ahead of time. I guess all three of these need to go this way a little bit more, even though it's still going to be tight. Well, here's the speaker baffle for the 12-inch speaker that won't allow the tube to fit in. So I'm thinking, what can I do? Because I really wanted to make it an amp. And then I remembered I had started building another amplifier with a 10-inch, and that's what this is. And this 10-inch speaker I have will fit in there, and it won't, it'll allow clearance for the tubes. I had this speaker in an old Ampeg VT40 back when I was like 22 or so. Blew it out. It was one of the 4 replacement speakers in an Ampeg. I blew it out anyway. It ended up in my mother's attic for like 40 years or so, along with the transformer that is going into the same amplifier. So, and it was blown out, so I sent it to Weber, and they reconed it and upgraded it to 50 watts. So it might work out pretty good for this. So this is just, see, it's a little bit bigger the whole way around. So I can trim it off and see if we can make this work. Alright, here's a 10-inch baffle. I had to cut it down a little bit to get it to fit. So I think it's going to be okay. I just got to put the screen on it, and perhaps we will then be ready to rock. Got the new baffle cut down. Everything seems to work out pretty good. There we go. Plenty of room for the speaker. I went with the stock 250 ohm bias resistor, but I've got 40 milliamps, about 380 volts. So what is that? It's 15 watts on one tube. I'm monitoring the current through a tube with a bias probe. So I'm going to change that resistor to, I don't have a 470, so I'm going to change it to a 500 and see what happens. Got a 500 ohm in there, and I also managed to char the outer coating of the capacitor. I hate when I do that. Anyway, yeah, got a 500 ohm in there, but still we've got about 29 milliamps at 411 volts, which is about 11.5 watts. I'm going to change the resistor up to 1K. Let me try that. Okay, I've got a temporary 300 ohm resistor tied to the 500, and got 21 milliamps and 434 volts. So we're still up there. As the current goes down, the voltage goes up for a given wattage, but I may eventually wind a transformer with a lower voltage and put in here. I'll have to think about that. I'm thinking about building another transformer with a lower voltage. This voltage here, 377, was what I measured on an old Tweed Amp, an original one from the 50s that I had a long time ago. I wrote some of the numbers on the schematic. So at this point, I'm up to 444 volts. So I'm thinking, well, maybe I could just disconnect this right here and put another dropping resistor in there and try to get it down to that. Why not? Yeah, there's the high voltage coming off of the 5Y3, so if I just put a little standoff down on that nut there, I can remove these wires, put the resistor from there to there, and then hook the wires onto the other end. And, just to see. I can still wind the transformer, but, it'd be nice to get that down to a more moderate voltage to just make the tubes last longer. So let me see if I can get something set up there. After trying different resistors in there, and having it go all over the place, I finally just hooked up a rheostat and dialed it in. I'm using my solder vise to hold it in place. And yeah, so I've got this, which is pretty good. I think it's around 8.5 watts or so. So I think, let's see. So I just have to measure that and try to get some kind of resistance that's going to be not only that value, but also able to take the wattage. Alright, a 1K seemed to do the trick. I got a 10 watt in there. Hopefully it won't get too hot. And we're at like 363 volts with about 18 milliamps, which is 6.5 watts. So I think I'll test this for a while and see what it's like. At least it should prolong the tube life if nothing else. Hopefully it'll sound good. August 10th, 1519. Magellan and 5 ships leave port to circumnavigate the world. July 20th, 1969. Neil Armstrong steps on the lunar surface. Mere footnotes compared to the throwing of this switch.
Thank you.